So in section 7.5, we first need to remind ourselves what an exponential equation is. We have seen exponential functions. We haven't yet solved them yet, but we graphed them. So any equation that contains the form b raised to the cx power, such as a equals b raised to the cx power, the key thing is that the exponent includes a variable. Okay? If the variable is up in the exponent, that makes it an exponential equation. All right? So we can then use logarithms to solve exponential equations, and we can use exponents to solve logarithmic equations. Okay? Big idea that we need to remember, something that you need to write in this little area right here. Okay? There are two properties, and I'll show you where they come from here. But if we have log base b of b raised to the x power, log base b of b raised to the x power, that gives us x. Okay? It's not technically true what's happening here, but you can think of it as that log base b is canceling that base of b, leaving you with the x. Okay, you can think of it that way. That's really not what's happening, but we can think of it that way. All right? Same thing for this other property here. If you have b raised to the log base b of x power, okay, if you have b raised to the log base b of x power, that is going to give you x. Now, again, you can think of it as canceling. That's really not what's happening, but for your purposes in this class, you can think of it as that base of b and that log base b are canceling out, leaving you with the x. Okay? Now, real quick, where do those come from? Let's take a look over here. I started writing on the board here. We have log base b of x equals y. And so therefore, I can use my definition of logarithms to write that in exponential form, b to the y power equals x. Okay, that we've known already, right? That's nothing new. I'm just going to be using that rule, that definition of a logarithm, and saying that if I take b to the y power and say that that equals x, what if I go through and take the log base b of both sides? So I want to say I've got log base b of b to the y power and log base b of x. Right? Well, what does that equal? Look at the very top line on the page. Log base b of x equals what? Y. Right here. Log base b of x equals y. So therefore, log base b of b to the y power simply equals y. Okay? Well, let's do the other rule we're going to see. If we go through, and what if we start with log base b of x equals y, and now I'm going to do something called exponentiate. See if I can spell it correctly. Exponentiate, something like that. Okay? Exponentiate, it is a verb. We want to exponentiate both sides. And what that means is that we want to make both sides of that equal sign the exponent of something. Okay? And so I'm going to use my base. You always want to use the base of your logarithm. So my base of my logarithm is b. So I'm going to say b raised to the log base b of x power equals b raised to the y power. So rewriting that, b raised to the log base b of x equals b raised to the y power. I have now exponentiated both sides. And real quick here, what does b raised to the y power equal? B raised to the y power equals x. So b raised to the log base b of x power is simply x. Okay, we need to know those two properties. Okay, those are what we're going to use today to solve our equations. Now, they simply come from the definition of a logarithm. Okay? Questions? All right, so let's look at our first example over here. Solving an exponential equation when we have a common base. When we have a common base. So, basically, we've solved a problem like this before. We've done this before. Okay, when we were evaluating. Remember when we were evaluating logarithms at first? We had, say, log base 2 of 8. And I had you guys say, okay, that equals y, and then we rewrote that, 2 to the y power equals 8, and we rewrote them in the same base. That's the same process here. Let's rewrite 16 to have the lowest base possible, which is a 2. 2 to what power is 16? Fourth, yeah. Raised to the 3x power. And then 8, well, that's going to be 2 raised to what power? Third. Cool. So if we have a power raised to a power, we multiply. So I have 2 raised to the 12x power equals 2 raised to the third power. And so now I know that 12x equals 3. Solving that simple one-step equation from Algebra 1, we see that x equals 1/4. Okay? We've done that process before, yes? Yes. So let's learn the new process. What is going on here for the new process? Well, if I start out with my equation, 16 to the 3x power equals 8, I want to use logarithms. I have an exponential equation. I know it's exponential because I have an x up in the exponent. Okay? I got to get that x out of the exponent so that I can solve for it. So I'm going to use logarithms. Now, in using logarithms, we want to eventually be able to use our calculator. So technically, I could use any base logarithm I want. But if I'm using a calculator, I'm limited to which two bases? Base 10 and base e. So it's the natural log and the common log. Okay, those are my only two bases that I can use if I want to eventually use a calculator, which I do. Okay, so I'm going to go ahead and take the natural log of both sides. By the way, folks, why did I pick natural log? Just because it's one less letter to write. There is no difference between using the two. Okay, but if you start using natural log, you have to stay using natural log in that problem. If you start using the common log, you have to continue to use the common log in that problem. You can't switch back and forth halfway through the problem. Okay? All right. So I took the natural log of both sides. Now what that allows me to do then is to take that exponent and move it out in front of my logarithm. So 3x natural log of 16 equals the natural log of 8. Now I can solve for x by dividing both sides by 3 natural log 16. Okay? To find this answer, I got to grab my calculator. So grab your calculator. We need to make sure to plug it in properly. When you plug in the natural log, for natural log of 8, your calculator is going to automatically give you a parenthesis, right? So go ahead and tell it natural log of 8, end that parenthesis, then push divided by. Now here's where we really have to be careful. We have to tell it that we want to divide by that entire quantity 3 times the natural log of 16. So in our denominator, when we say divided by, start with a parenthesis. And then say 3 times natural log, right there the calculator is going to give you a parenthesis. 16, you have to now end 2 parentheses. Type it in that way, calculator knows exactly what you're talking about. Okay? And when you push enter, what are we getting? Round it out to 4 decimal places for me. Oh, of course it comes out to 0.25. Why? Because it's supposed to equal 1/4. Exactly. That is the same thing we got over there. So if you're able to write it with the same base, you could do it the way we've learned before. But most of the problems that we're working with now, you're not going to be able to do that original method. You're going to have to use logarithms to solve. So let's try another one. For example here, what is the solution of 15 to the 3x power equals 285? Well, in that problem, there is no way of rewriting 15 and 285 to have the same base. Okay, 15 is just 15 to the first power, but 15 squared is 225. So there's no way to make 15 to some power give you 285. So we can't use the original method. We have to go through, and take 15 to the 3x power equals 285, and we need to take the log, or take the natural log, of both sides. Again, my preference is the natural log because it's one less letter to write. Okay, if you want to use the common log, just logarithm, that's fine. Do that. There is nothing wrong with that. So I have taken the natural log of both sides. So I can then take that 3x, that was my exponent, and move it out in front of the logarithm. So 3x natural log 15 equals the natural log of 285. Now I can solve for x, again, by dividing both sides by 3 natural log 15. So the 3's cancel, natural log 15's cancel. I get x equals, well now again, you got to be careful how you type this one in. All right, you're telling your calculator you want the natural log, parenthesis, 285, divided by, give yourself a parenthesis there on the bottom, 3 times natural log 15, end both parentheses. You've got to tell the calculator exactly what it wants. It can't read your mind. Okay? So we should be getting then 0.6958. People agree with that? Let's round out to 4 decimal places. If it does not tell you what to round to, round it to 4 decimal places. Okay? If it says to round to a specific decimal place, then that's, of course, what you need to round to. All right, I'd like you guys to try one on your own. Right below that, we have 7 to the 4x power equals 800. Please take a moment and solve for x. Go. Okay, so once we went through and solved this, we should be getting x equals natural log, or if you use the common log, that's fine, of 800 divided by 4 natural log 7. And when you plug that into the calculator, we should all be getting approximately 0.8588. All right, look at the problem right next to that. We have 4e to the 2x power plus 2 equals 16. All right, there's a lot going on in this problem. But please keep in mind, when we were going through and using that logarithm property, the property we were using was log base b of b to the x power, and we were saying that we can move the x out in front, right? So we had x times log base b of b, right? Or something along those lines, right? Moving that exponent out. But notice, we were taking log base b of whatever, of just this item to the x power. There was no coefficient out there. It wasn't 3 times b to the x power, right? So therefore, we have to get this by itself. You've got to get whatever's being raised to the exponent by itself first. Okay, so we're going to have to subtract 2. So 4e to the 2x power equals 14. Right, here's what I'm talking about. If you took the logarithm of both sides, or the natural log of both sides, you can't use that exponent property. You can't move that 2x out in front. Okay, because that 4 is in the way. That 4 is in the way. So we've got to get rid of that 4. We only want the item that's being raised to the exponent. Okay, so e to the 2x equals 7/2. All right, now we can worry about logarithm. Now, how many of you in here have been using the common log? Just log, log. Okay, I know a couple of you have because I've been looking at your papers. All right, so a few of you have been using that. You want to think ahead. Okay, same thing for those of you, if this was 10 raised to the 2x power, if you've been using natural log, you probably want to think ahead a little bit and think about what's going to make your work a little easier. Because if you've been using logarithm, the common log, you at this stage want to switch over to natural log. Because we have e raised to the 2x power. If I take the natural log of both sides, what is the natural log of e raised to the 2x power? Think back to our properties that we talked about today. Because what does natural log really stand for? Nope, doesn't stand for e, it stands for log base e, right? So log base e of e raised to the 2x power. What do we get? 2x. Log base e of e cancels away, we get 2x. Equals the natural log of 7/2. Okay? That was that rule that we talked about. Let me go back to that rule real quick. Right over here. Log base b of b to the y power equals y. So we just dealt with log base e of e to the 2x power, so that must equal 2x. Right? Okay. Let's finish the problem then. To solve for x, what do we need to do? Divide by 2. So, please remember, you are not taking 7/2 divided by 2. You're taking the natural log of 7/2 divided by 2. So in your calculator, you need to say that you're taking the natural log of 7 divided by 2, and then you're taking that quantity divided by 2. Okay? Make sure we're typing it in properly. So, what are we getting for our answer?
0.6264.
Correct. So, if there's no questions on that, let's go ahead and go to the back. Because everything we've been doing up to this point have been exponential equations. Well, what about the logarithmic equations? Okay, logarithmic equations are easy to identify because what? They have a logarithm in them. Yeah, they're just that easy to identify because they have a logarithm in them. It's fun to say, isn't it? All right. So, looking at this, because it's written in a sentence, oftentimes the logarithm gets lost. So what I'm going to do is I'm going to rewrite the equation here. That is saying log of 4x minus 3 equals 2. We need to solve for x. So that means we need to get rid of that logarithm. What is the base of that log?
10.
Base 10.
Yes.
That is the common log. That is base 10. So therefore, we need to actually use that base. It's not just something that we guess at as far as what we can exponentiate by. We can't just use any number to exponentiate. We want to get rid of that logarithm. Therefore, we want to use the base of that logarithm. It's currently base 10, so we want to use 10. 10 raised to the log of 4x minus 3 power equals 10 raised to the second power. That is that process I talked about at the beginning called exponentiating. right? We're making each side of that equation the exponent. When you do that, 10 raised to the log base 10 essentially cancels away, leaving us with 4x minus 3. And that's going to equal 10 to the second power, which is 100. So we've gotten rid of our logarithm. Now it's a matter of solving a simple two-step equation from Algebra 1. Add 3 to both sides. Divide both sides by 4. So 103 divided by 4 is going to be 25.75. Let's try another one. Let's take a look here. What's the solution of log 3 minus 2x equals negative 1? So again, a lot of times that log gets lost, so I'm just going to rewrite that equation. What's the base of my logarithm? 10. So to get rid of a logarithm, I have to exponentiate. So I'm going to use 10 as my base for the exponents. So 10 raised to the log base 10 cancels away. So 3 minus 2x equals 10 to the negative 1 power is 1/10. Continue solving. Subtract 3 from both sides. Negative 2x equals, wait, I need a common denominator. That should be 10. So negative 3 is negative 30/10. So 1/10 minus 30/10 is negative 29/10. Divide by a negative 2. Wait a minute, I don't like fractions involved in fractions, so I'm not going to divide by a negative 2. Instead, I'm going to multiply by a negative 1/2. Negative times a negative is a positive, 29/20. Yes, sir?
How'd you get the negative 29
From taking 1/10 minus 3. 1/10 minus 30/10. Let's try another one. Hey, this one right below. That looks like that should be easy. Natural log x equals 2. Natural log x equals 2. How am I going to get rid of that natural log? I can't solve for x until I get rid of the natural log. Okay, so what do I do with that e?
Raise it to the natural log of x.
What's that fancy word? Exponentiate. Meaning I use the e as the base for the exponents. So e raised to the natural log x equals e squared. Natural log e raised to the natural log goes away. I get x equals e squared. If they wanted an exact answer, that's my exact answer. Because remember, e is that irrational number like pi, right? You would give answers in geometry all the time as 3 pi because they wanted the exact answer. Okay? So e squared is the exact answer. If they wanted this rounded to 4 decimal places, what would we get?
7.3891.
Okay? Questions? Doing okay? Let's try one more. One more. What are the solutions of natural log x minus 3 quantity squared equals 4? All right. In this problem, I actually told first hour wrong, so I have some makeup to do tomorrow. Okay? Please pay attention to the fact we actually cannot, since we don't know what x is, we cannot use the properties from 7.4. I cannot say take that 2 and move it out in front. Okay? The reason I can't do that is because if you look back at your 7.4 notes, it'll say for that property only holds true if what you're taking the natural log of is a positive number. So if I have a positive number squared, then yeah, I can take the 2 out in front. But do I know for sure that this x minus 3 is a positive number? No, I don't know for sure. Remember, I cannot take the natural log or any logarithm of a negative number. So if x minus 3 happens to be a negative number, can I still work this problem?
No.
Be careful. I'm taking this negative number, x minus 3, and doing what with it? Squaring it.
Oh, so
What's a negative number squared? Positive number. So regardless if this is negative or not, I'm still taking the natural log of a positive number. So all that is okay. The issue is I cannot take this 2 and move it out in front, because that only works when this number is positive. Okay? So because of that, we just have to work with the natural log, which I'm sure many of you were thinking, hey, that's what we do anyways. But I wanted to make sure to clarify that if those of you thought that, hey, maybe I should take that 2 out in front and get rid of it first, you can't do that here, because we don't know whether or not x minus 3 is actually a positive number. Okay? So our best bet is to get rid of the logarithm first. Okay? Best bet is to get rid of the logarithm first. So to get rid of a natural log, what do? Big fancy word? Exponentiate. What do I use as my base for my exponent? E. E raised to the natural log of all that is going to equal e raised to the 4th power. E raised to the natural log goes away. So I get x minus 3 quantity squared equals e to the 4th power. Now I need to go through and get rid of that exponent of 2. How the heck do I do that? I do what? I square root both sides. I take the square root of both sides. So the square root cancels with the square, leaving me with x minus 3. And what do I get when I take the square root of e to the 4th power? E to the 2nd power. But wait a minute. Who put in that square root? I did. So it's positive and negative e to the 2nd power. And now if I add 3 to both sides, my exact answer is 3 plus and minus e squared. Okay, so there's the exact answer. Let's go ahead and find our approximations. So x is then approximately, well, again, e squared. We just did that in the last problem. E squared is 7.3891. So then what is 3 plus 7.3891? Yeah, I hope you didn't grab a calculator for that one. Okay? It's 7 plus 3. All right. Well, now we need to do 3 minus e squared. 3 minus 7.3891. Negative 4.3891. There's our approximations. Okay? So it all depends on how they want the answer. If they say round it to 4 decimal places, then of course these are then the answers I'm looking for. Okay?